Alright guys, tell me what this is here. Why would it be 2?
Because it's base squared.
Because 7 squared equals 49. Not only is this a way to check yourself, but these are alternate versions of the same statement. This is a logarithmic version of the statement. This is the exponential version of the statement. You guys see what I'm saying? And Mark will have the logarithmic one has a log in it, and the exponential one has an exponent. It's crazy why we call it the things we do. So what about this here? So just for the people that work here, yesterday, this is a bad day to miss. The whole thing about math symbols is they try to take the place of some long-ass question. So you have to internalize what the question is. So when you see a logarithm, it's the base is the base as it normally is. So the question the log is asking is, what power does this base need to become this? So the answer to a logarithm is always a power. It's the power that this base needs to become this. And how do you read this? Log. What is 2? It's the base. So log base 2 of 1/16. That's how you read this. So what would you do? How many 2's does it take to multiply to become 16? 4. And then how do you flip it? Negative. So -4. Because, how do I write the because statement? 2 to the -4 is 1/16. So there's no magic. If you open a math book that you haven't taken the math class yet, you see all these symbols and you're like, oh, this looks hard. It's just because you don't know what the symbols mean. You don't know what the question is that the symbol is asking you. Okay. This example I had the other day was, if you do a square root, you actually aren't doing something to it. You're thinking backwards. What does it take 2 of to multiply to be 9? It takes 2 3's. But you've internalized what this question is. Right? You see the symbol and you read, you don't even really say the question yourself. You just kind of know what it means, what it wants from you. You've got to do the same thing with this weird-ass symbol. Right? Alright, so what about this here? Base 1/3. What you got, Jeff? 27. Ooh, that looks gross. I like that one. That is horrendous. And watch how you can build this. To make 1/3 become 27, the most obvious thing you have to do to 1/3 is going to involve doing what to it? Flipping it. So you know the answer is going to be negative. And then once you flip it, how many 3's do you multiply to make 27? 3. There you go. Hey, we're growing. Alright. Maybe. So if you were here, hopefully that's a good review. If you weren't here, you might need a little more than that to catch up. More people! Let's do something we didn't do yesterday here. Oh, shit. So the funny thing is, when I ask you to graph a function, I mean, somebody tell me, if you don't know what a function looks like, how do you start to graph it? What do you create? How do you graph anything? You have to get what's? Points. So I'm going to make a bunch of points. I'm going to make an XY table to get a bunch of points. So since I'm the one, I'm the human here, that's the function, I can pick whatever the hell I want to plug in there, as long as it's possible. Now let me ask you this. Let me see if anybody realizes this. Remember what happened with exponentials? They were like this. This might be like 3 to the x or something. So this guy was doing what? This guy... What does this guy? Does this guy ever go across and go down here? Yay! No. What's it? It's getting really, really, really close to the x-axis, and we call that what kind of behavior? Asymptote. Asymptotic. Crazy shit. When you get really close to something, you get infinitely close to something, but you never touch it. Mathematically, that's an asymptote. That thing that you get close to is the asymptote. And I talked about Zeno, and he's trying to get to the next city. If you were here yesterday, you might remember that. Okay. I said, just lie to the fool, and he'll get there. All right. Now, what does this mean, though? What does this imply? This means that I can't raise 3 to a power and make it become negative, let alone 0. I can't even make it become 0. I can make it get really close to 0. If I raise it to a really negative number, what's 3 to the negative 1,000? It's 1 over 3 to the 1,000. That is a remarkably small number. Do you guys agree with me? 1 divided by really freaking big becomes really freaking small. So I can make it as stupid close to 0 as I want. I just can't make it equal 0. So what I'm trying to say about this then is, this is going to be 2 to some power equals x. So what's x got to be bigger than? What can x not equal or be less than? Same thing I'm saying here.
0.
The output here can't be less than or equal to 0. So the input here can't be less than or equal to 0. They're inverses of each other. Alright, so if you're going to make a table of values for any function, you have to know what values am I allowed to use, so you pick values that will make sense. Alright, so I'm going to make this table of values. I'm going to be smart about what I pick. So for example, let's leave some room. Leave like 2 spots here. I'm going to obviously use 2. I'm going to use a freaking base. That's the easiest thing. So when I plug a 2 in, what do I get? What's log base 2 of 2? What's log base 2 of 2? And again, what question are you asking yourself when you see this? Yeah, it's 1. What power does 2 need on it to become 2? First power. Or another way to say the same thing is, how many 2's do you have to multiply to get 2? You just need 1. 1, 2 makes a 2. It's crazy. What's the next number up that I want to use? Do I want to use 3? Shit, no. What do I raise 2 to make 3? I don't freaking know. But 4, what do I raise 2 to make 4? Second power. What's the next number up that I'd want to use? Careful. 8. Because how many 2's do I have to multiply to make 8? 3. How do I keep getting the numbers that I want to put in here? I just keep multiplying by 2. Start with 2, multiply by 2, multiply by 2. I'm guaranteed to get a nice whole number answer. Yes, sir?
So basically, nevertheless, just keep doubling.
Yeah, the number inside that you want to use to keep doubling. So if it was log base 3, I would use 3. Now be careful now. Why is it doubling here? Because it's 2.
Yeah.
If it was 3, I would only use 3 and then 9 and then 27.
Yeah.
Multiply by 3.
Yeah, that'd be triple.
Because that would be numbers of 3's. That's what logs are really interested in. How many of the base does it take to make the input? Now, if I keep multiplying by 2 in this direction because the base is 2, what do I do this way? Multiply by 2 this way. Probably divide by 2 this way. I want to put 1 in there. What's log base 2 of 1? What's log base anything of 1? 0. I raise something to the 0 power to get 1. And what's this divided by 2? Divide 1 by 2, and you get 1/2. It's crazy. What's log base 2 of 1/2?
1.
Careful. 2 squared is 4. What do I raise 2 to get 1/2? Negative 1, because I still just wanted 2, right? What's 2 to the negative 1? 1/2. And that should be plenty of points now to graph, to get this graph. This is kind of cute. Here's what 2 to the x looks like very quickly. That's what 2 to the x looks like. So I'm just going to put that for reference. Here's log base 2 of x. What do I want? I got 1, 2, 3, 4. Screw 8. All right. 8's way out there somewhere. And then I got. So I got the point 1/2 negative 1. 1/2 negative 1. 1, 0. 2, 1. 4, 2. 8 would be 3, so you can see the form it's got. So what's really kind of cool is, what kind of number did we say we can't plug in there? We can't plug 0 in here, right? Or any negatives. So the way that looks visually is, if I keep plugging in 1/4, 1/8, 1/16, it's going to be negative 2, negative 3, negative 4. So it's going to keep going down, down, down forever. So that's where the asymptote goes now. The asymptote goes there. And look how it compares to 2 to the x. Here's 2 to the x. You can do it, Jeff. How do they look? How do they compare? There's 2 to the x, and there's the opposite function, log base 2 of x. They're opposite functions. What would you tell somebody? How does this look? What do they? How do they relate to each other, these two graphs?
Mirroring.
Say again?
Mirroring, like.
Mirror.
Yeah, mirror.
Mirror image. I'll put the mirror right there, and it's the mirror image of each other. Right? Okay, maybe. And that's actually how all inverse functions look. Whatever one looks like, the other one is the mirror image across this line. It's kind of neat. All right. We're right on the boundary of as far as we want to go in the curriculum for this class, but I just had to push it here a little bit. Okay, all right. So once you know how a function works, what the question is that it asks, and you can calculate values for inputs, then you can immediately make a graph of it. Because that's all it is. Pick some inputs, calculate the value. Pick an input, calculate a value, graph them. So I can make a graph of the damn thing if I know how to calculate values. Okay. All right. What else did we talk about yesterday? Let's see. Is there anything else from yesterday I want to talk about? I think that's basically everything we talked about yesterday. So just help me out here. What's log base m of m to the 11th power? I think I heard it. 11, right? Because again, what's the question? What do you have to raise m to get m to the 11th? You raise it to the 11th power. Another kind of way to look at it, since these two functions are inverses of each other, log base m and m to a power are inverses of each other, they cancel. That's kind of cool. Or you just look at it like, well, it's freaking 11. That's what it needs to become m to the 11th. I like it. What about, how about this? Let me try something different. How do I rewrite this as in the other format? Rewrite that from logarithmic to exponential. How do I do that? It's sort of like that step we took when we checked the answer. What do I do? X x to the first power is 2. So I basically just solved that equation. So for really basic logarithmic equations like this, I can solve just by rewriting it. That's kind of nice. So here, let's do a quick view of what we just did there. How do I rewrite in exponential form? Something like this. Log base 7, 49 is 2. Rewrite that into exponential form. What would that look like? Why is log base 7 of 49 equal to 2? Because 7 squared is 7 to the second power is 49. I like it. So that's always true. It's not just a way to check it. If that's true, then this must be true. That's why it's a way to check it. So what about this one? Let's try one with no freaking numbers in it at all. Log base x of y equals z. Yeah. Again, I don't know if I've said this much in this stuff, but the process of math doesn't give the first shit what's in the problem. The process just says, do this. So what do? I do that to that equals that. So how would I rewrite this? X to the z equals y. Bam. If that's true, that means that this is true, and vice versa. It's not that big of a deal. If you remember what the question this is asking, of course that's the way to rewrite it. What power does 7 need to become 49 to? So how would I write that a different way? Well, 7 squared is 49. They both say the same thing. It takes 2 7s to make 49. That's what they both say. It takes zx's to make y, whatever those things are. Alright, cool. The other way is a little bit harder. But notice this. What's the output in this first statement? What's the output? What's the output here? What's the output? What's the answer?
49.
That's the input. See how 49 is on the inside? That's why I call it the input. It was put in to the log. What's the output? 2. That's the output. That's the input. What did I put into the log? Base 7, 49. What did I get out of it? 2. Now look at this. What's the output here? 49. And what's the input? 7. They just switched. That's how opposite functions act. They'll just switch the two. So if 3 cubed is 27, so 3 is the input, 27 is the output. What's the cube root of 27? Now that's the input. What's the cube root of 27? 3. Input, now it's output. Output, now it's input. That's how opposite functions act. One, if it's the opposite function, it's going to take the output of one and make it become the input. It's going to undo what was done. I did something to 3 and I changed it, so the cube root's going to make it go back to 3. So, that's going to help us out with this. Rewrite in log form. This is the one that's a little bit harder. Yeah, they're log. What you got, Jeff? 2 to the negative 3 equals 1/8. So the first question is an easy question. Can somebody please help me and tell me what the base is? 2 is the base. So when I rewrite this to be log base 2, so now I can look at it two kind of different ways. The answer to a log is what's the answer to a log always? Why did we say this was 2? Because 7 needs 2 as a power. So the answer to a log is a power. So what's the power in this statement? -3. Bam. And the output now becomes the input. So how do you check? This is a little bit harder way to go from exponential to logarithmic, but you can just really quickly say, check yourself. 2 to the -3 equals 1/8. Okay, good. I set it up correctly. Whatever the input was is now the output, and whatever the output was is now the input. Maybe. So you guys try this one. Rewrite this one in log form. Yes, ma'am.
A to the power of C equals B.
Okay. No. So if I had 2 cubed is 8, is it true that 2 to the 8th equals 3?
No.
Hell no. So I need to write something that if this is true, then what I write is also true. So there's 2 things here. You can't just change those and expect it to be still true. There's an easy counterexample. No good. Secondly, my question is rewrite in logarithmic form. So your answer probably should have a log in it. I like it.
Log A C
Log
equals B. Base A.
base A, good. Log base A
C
of C
equals B.
equals B. How do I know I'm good? Because the B is the power, and a log equals a power. The output is now the input, and the base is the easy one. The base is just staring you in the face. It's the base. Okay, maybe.
Drop base.
Don't drop the base. Well, actually, yeah. Drop the base a little bit. Chip it. I mean, there's nothing else I can do. I can turn it around. Let's see if that messes you up. D equals W to the second power. Rewrite that in logarithmic form. Wait. Okay.
Log W, base W. D, base D. No, not base D. D
Of D.
of D equals 2.
Okay. So the output's the exponent, the base is the base, and then the output. What am I talking about? The output of this is the exponent, what the input used to be. The old output is now the input. I like it. So there's 2 different outputs. You got to be careful how I write this. And how do I check it really quickly? W squared equals D. W squared equals D. I know I've got it right. So that's the harder way to go, is from exponential back to logarithmic. Okay. Okay, cool. So that's one little skill you need to have. So let me ask you what hopefully is a silly question here. So please, dear God, don't think you're wrong because it looks too easy. It's not a trick at all. Can anybody tell me what the answer to this is? So what's the value of x? I mean, you guys see the idea here. I mean, it's staring right in the face. No tricks. What does x have to be to make this true?
5.
5. Okay, great. How do I know that? Because the bases are already the same. The only thing that I still need to be the same are the powers. So then I can just set this power equal to that power, and I'm done. Yay! So let's go one step up from there. What if I had this?
X equals 8.
Yeah, so what would you say? How would you set up an equation? The bases are the same. So what am I allowed to do? X minus 1 has to be 7 for that to be true. So then x is 8. Isn't that crazy? That's a remarkably simple exponential equation. If I can make the bases the same, or if they already are the same, shit, that's awesome. So what if they aren't the same already? What if I have 8 to the x equals 4 to the 2x minus 1? So what you gotta first realize is, what number are both of those bases based on? So what do I mean by that? They're both something to a power. They're both some number, the same number to some power. What are they both based on?
2.
2. What's 8? I'm going to replace 8 with 2 to the 3rd power. And what's 4? I'm going to replace 4 with 2 to the 2nd power. So what am I trying to do? Those were stupid easy. Those are easy. That just, bam. That's, please, dear God. So if the bases aren't the same, I go, well, shit, can I make them the same? Because then it'll be just as easy as that shit. Well, the thing you got to remember now is, what the hell do you do here? So, for example, what is x squared to the 5th power? Let me help you out. Don't say 7. 7's bad. 7 is x squared times x to the 5th. That's when you add. 2 x's, 5 more x's, I get 7 x's. Here I got 5 groups of 2 x's. 5 groups of 2 is 10. You multiply. Yeah. When you multiply, you add. Well, a long time ago, some student came up. When you multiply, you add. And there was more to it, but that's all I remember. I like that. When you multiply things with powers like bases, you add the powers. And when you raise them, you multiply. It's always like offset by one operation. I don't know if that makes any sense. So here, what do I get here? 2 to the 3x equals 2 to the, oh shit, you gotta be careful here. 4x minus 2, I like it. And now, what equation can you set up? The bases are the same, so what's the only thing that you still have to force to be the same? What's got to be true? The bases are the same already. So what's got to be true about these? In order for this equation to be true, these have to be equal. Same thing we were doing earlier. What did I do when the bases were the same? I made the powers equal. That's the only way they can be equal, is if the powers are the same. Because the bases are already the same. So then 3x must be 4x minus 2. Subtract 4x, divide by negative 1, you get x is 2. How do you check that? Same way you check anything. Try to take over the world. No. Same way you check anything. You plug 2 in, see if it works. 8 squared is 64. 4 to the 4 minus 1 is 4 cubed is 64. It works. I love it. Here, you guys try this. So I have no idea what the answer is going to look like, but let's see. What number are these both based on? 3. So 9 is 3 squared. 27 is 3 cubed. So then you can write, so the bases are now the same, you just need the powers to be the same. 10x plus 2 has to be
3x